In the next 6 minutes, I'm going to take you from outer space to inner space. In 1965, I read a book called The Deep Range by the author of 2001, The Space Odyssey. This is about a submersible pilot that would take an underwater vehicle out for weeks at a time, patrol undersea farming, patrol whale pods. He was a cowboy patrolling the deep range. And I said, that's what I want to do someday. That's what set me on my course to work on manned and unmanned underwater vehicles. From 1974 to 1985, I worked on the American Deep Submergence Rescue Vehicles. These vehicles were 50 feet long, weighed 70,000 pounds, and had 1,400-pound silver zinc batteries. They were designed to rescue submariners from downed submarines and bring them to other underwater submarines, but they could only operate for 8 hours, and they took 16 hours to recharge. And it would take 3 or 4 days to rescue crew from a downed submarine. I said, there's got to be a better way to do this. And in 1985 to 1988, I worked on a quarter-scale model of the nuclear-powered submarine Seawolf. It was 90 feet long, 10 feet in diameter, and because money was an object here, we had 60,000 pounds of lead-acid battery driving a 3,000 horsepower GE engine, and we would discharge that in 5 minutes at maximum speed. In 1993 to 2000, I worked on a 21-inch diameter by 20-foot long underwater vehicle. Weighed 2,800 pounds. It had 700 pounds of silver zinc batteries, and at minimum speed would last 12 hours, and at maximum speed, 1 hour and 15 minutes. There's got to be a better way. In 2005, Jim Moden, the fellow you've heard about, with the monopropellant fuel, came to me and said, I've been trying to use this on all of the nation's torpedoes because the current auto fuel is an environmental hazard. It's terrible. Mine's more energetic, and its byproducts are CO2 and water. So I said to him, why don't we apply this to underwater vehicles, show how well it works there, how environmentally friendly it is, how gas and go it is, so we don't have to spend 8 hours recharging or 16 hours recharging, and we'll go there. So the first year, we got a little bit of Raytheon money, and we came down here and we said, can we even turn it over with a steam fuel source onto a steam engine? And yeah, we did that. So then they gave me some more money, and they said, can you come down here and create a combustor and a steam generator and drive the Solar One engine? That was the only thing we had available to test that. And we measured the efficiency. And we got the efficiency numbers both dynamically and thermally that said this is a good idea. And this year, Raytheon has funded us for 2 36 horsepower engines. And we took those vertical shafts and we turned them horizontally because we want to drive a propeller and we want to drive an electrical generator off of that. We monitor everything, we record everything, because it's about growing the efficiency of this, measuring every single part of that engine and that fuel chain and the control system, optimizing all of that. Because what do we want to do with this? We want to power manned and unmanned underwater vehicles. We want to power remotely operated vehicles. Currently, our oil rigs are operating in 3,000 foot of water, and they have a power cable that has to go all the way down there. And the ocean current sweeps that cable away. They spend 40% of their energy fighting the ocean current. We can change that to an engine that can go down there, they can operate, and they can come back up and gas and go. That's the kind of operation we want. We want to take arrays that are underwater and leave them there for 6 months. We need to have a fuel source that can go do that, and maybe even a fuel source where somebody can come by with another vehicle and refuel it. They're gateway buoys. There are many, many applications that we want to do. By our analysis, from the demonstration that we did last year, we predict that we can take an underwater vehicle and go from San Diego to Hawaii underwater at 7 knots, or we can go from San Diego to Catalina Island and back 2 times underwater at 20 knots. Those are game changers. That's what we're all about. We're about developing the engines that can give me that vision of being out there for a long time. And so now, 2015 will be 50 years since I read The Deep Range. And I will be sitting in a nice, comfortable control room while that unmanned underwater vehicle is out there freezing its butt off.